Welcome back to Climate Current, where we look at some of the major climate change issues that are facing us over this amazing world of ours. Today, we're going to look at harnessing the power of the ocean as a renewable energy source. Is this possible? And what are the types of work that goes on to be able to do so? Firstly though, please like, subscribe and ring the bell notification. So why do we do this type of work? Knowing about climate change helps us make better choices about energy, transport and living sustainably. Being prepared keeps us aware of climate change issues and get ready for extreme weather events like storms, floods and heat waves. We also know that businesses and government need to prepare for climate impacts in order to be able to protect jobs and the economy. Health is very important. Knowing about climate change helps us tackle issues caused by heat, pollutions and diseases. So let's launch into the video. We all know that there are many different types of renewable energy sources that are out there. Wind turbines is one that we often see and controversial. We know that solar energy from the sun has been around for a long time. So too as harnessing the river for hydropower and energy production through those means. But can we do this from the ocean? We know that around the world many different systems have been tried. Tidal stream system, wave energy, tidal barrage system, and ocean thermal energy conversion. We know that some of these systems have been around for a very long time and they are producing megawatts of energy all over the world. But why the ocean, you may ask? Well, it's pretty simple. 71% of the Earth's surface is made up of water. To be able to harness the natural movements and temperature differences in seawater, we can then generate electricity. The global potential alone is estimated at 3,000 gigawatts, which is significant. Securing and utilising the energy and the rise and fall of the tides to turn turbines to producing reliable and sustainable energy is the ultimate goal. But how did we get here? The concept of tidal energy has been around as an idea and then in concept for a long time. Energy crisis in the 70s saw the technology explode and more work being done, particularly around ocean thermal energy conversion and wave energy. In the 80s and 90s, the advancement in technology allowed us to be able to look at a whole different range and a whole different light. There were many things that were tested in the ocean technologies, and several commercial tidal wave energy projects were initiated. In the early 2000s, industry continued to grow. Development of more advanced and large-scale projects, notably the development of MyGen Energy project in Scotland, became operational in 2016, one of the largest tidal energy projects in the world. Overall, companies have still continue to do research, but they've been doing this for about 100 years and have made significant progress in recent decades. Today, energy remains a key focus for us, particularly in regards to the renewable energy sector. Ongoing research will look at improving efficiency and reliability and cost effectiveness of ocean energy technologies. Government and private companies are investing in pilot projects and in exploring new ways. So let's have a look at some of these different systems. Firstly, tidal wave energy. This is where water moves in and out past turbines with the ebb and flow of the tide. Turbines turn generators and produce electricity. Electricity is then returned to the shore. Tidal current flow system relies on the flow and movement of the tidal currents to generate electricity. This renewable energy source takes advantage of the predictability and periodic nature of tides. Tidal turbines, which resemble underwater wind turbines, are placed in areas of strong tidal currents, such as narrow straits and around headlines. As currents flow through these turbines, they convert kinetic energy into mechanical energy, and this is transformed electrical energy through a generator. One of the major advantages of tidal flow energy is the high predictability compared to other renewable sources. We know that the tide will ebb and flow. Ocean thermal energy conversion, simply put, is a transfusion of cold, deep water with warm surface water, and using that difference to be able to evaporate, and then use the evaporation process to turn turbines at the top in order to be able to produce energy. The tidal barrage system simply uses the ebb and flow of tidal processes to be able to produce electricity. The controlled release of water through turbines generate power. The flows can be modified to be able to have impact upon migrating fish, and additionally change the different types of dynamics that are required environmentally. So what are the pros and cons of each systems that we looked at today? For the barrage system, we know that renewable energy is predictable. Tidal barrage is reliable, predictable, renewable energy source. Once it's set up, there is low cost in terms of the operation. Cons, well, there's a high initial setup. The costs are pretty inhibited in regards to the establishment. Environmental impacts, tidal barrage can disrupt local ecosystems and alter natural tides and flows. Tidal stream system, it's environmental friendly. Tidal streams can generate electricity without emitting greenhouse gases. It's predictable. Like with tidal barrages, we rely on the ebb and flow of the tidal systems, the patterns and consistent reliable energy source. High initiation costs are against, and again, the protection of environmental impact, while less intrusive, can be a major factor as well upon the fish migration and seabird habitat. For wave energy systems, abundant renewable relies on the untapped energy of the ocean, kinetic energy, low carbon footprint, electricity from just the wave energy moving around and doing what it does every day. Against their high cost, the technology is challenging. Environmental navigation is an impact. Wave energy can impact upon marine ecosystems and wildlife as well. For ocean thermal energy conversion, it's a continuous renewable source. We're using cold and deep water to generate electricity. Additional benefits can provide desalinated water and support agriculture and provide cooling for buildings, offering multiple benefits. Against, there's a high impact in regards to the cost initially of setup. Environmental concerns are also major factors. Alternating water temperatures and nutrient distributions can all affect marine life and local ocean dynamics. So there you have it. For mankind, there is much more to learn about in regards to being able to tap into the unlimited power that the ocean has within itself. We must learn to work with this and harness this unlimited power more effectively, not just for our generation today and tackling climate change, but for the benefit of future generations. Thank you, and please be sure to like, subscribe and ring the bell notifications.